Hey everyone. So in the previous video we were talking about oxidation and reduction, and we saw that these processes take place simultaneously. We saw that reduction is actually the gain of electrons, which is normally done by the nonmetals. So they gain electrons based on how many electrons they need, and they become negative charges. So that is reduction. Oxidation is the opposite. So oxidation is the loss of electron and making a positive charge. Normally the metals do it. And it's not just one reaction going on at one time, it's a simultaneous process. So metals always lose electrons by becoming a positive charge. Non-metals gain the same electron and they become negative charges. So it's a process which involves both. Oxidation involves the loss of electron and making positive charges, even if it's from +1 to +2, or perhaps from +3 to perhaps +4. Reduction is the gain of electrons, so it's a decrease in charge. Whatever the charge was, by the end of the reduction, the charge decreases. It becomes -1, -2, -3, depending on obviously how many electrons you're gaining. In today's session, we're going to be talking about redox in terms of hydrogen and oxygen, because it's a simple reference for us to see redox reactions without going into much of the electronic detail. So we have reduction and we have oxidation, and both can be described in terms of hydrogen and oxidation. Now let's first talk about oxygen, which is normally O2, or perhaps can be written as a single oxygen as well. The name implies, oxidation is basically gain of oxygen, or you can say reaction with oxygen. It involves the reaction of any element, virtually a metal or a non-metal, just with oxygen. For example, sulfur reacting with oxygen to make sulfur dioxide would be oxidation of sulfur. Carbon reacting with oxygen would be carbon dioxide, again the oxidation of carbon. Perhaps silica reacts with oxygen to make sand, or you can also call it silica. That is again oxidation of silicon. Reduction is the opposite, so it is the loss of oxygen. If something loses their oxygen, it is a reduction for them. For example, hydrogen peroxide, when they react, it forms water molecule and loses the oxygen. So previously hydrogen peroxide involved two oxygen atoms in the molecule, but by the end it involves only one oxygen atom, the other one has been lost. So at the end of the day, it's a kind of reduction process because you're losing your oxygen. So generally, whenever an element or a compound is losing its oxygen, it would be reduction. For example, SO3 gas often loses one oxygen and makes SO2 gas. I'll balance it, but you can see sulfur had initially 3 oxygens, but by the end of the reaction, sulfur has only 2 oxygen atoms. So that's a loss of the oxygen, and that is obviously reduction. In terms of hydrogen gas, it is totally the opposite. So a reaction with hydrogen is reduction. Reaction with hydrogen. For example, carbon reacting with hydrogen gives you methane. That's reduction. Nitrogen reacting with hydrogen gives you the ammonia gas. So that is reduction of the nitrogen. The opposite would be the oxidation. So loss of hydrogen. For example, it's a very common compound CH3OH, which is methanol. Methanol loses the hydrogen gas and it forms methanol. CHOH. So methanol, it has to be balanced at the end of the day, but what you get is loss of hydrogen, which is oxidation. So when any element loses the hydrogen, or any compound loses the hydrogen, that is obviously a oxidation process. Let's try out few examples and let's see what's going on over here. For example, it was nitrogen. It reacted with hydrogen to, let's suppose, give you ammonia, and later the ammonia burnt in the oxygen to, let's suppose, give you nitrogen dioxide gas. Let's call this step number 1 and let's call it step number 2. Step number 1 is technically a reaction with hydrogen, so that must have been a reduction. Step number 2, on the contrary, is a reaction with oxygen, so that must have been an oxidation. So hydrogen reacts and that's reduction. Oxygen reacts, that's oxidation. For example, carbon reacts with carbon dioxide to give you 2 molecules of carbon monoxide. Now to make this equation simpler, what I'm going to do is I'm going to write it another way. Carbon reacts with carbon dioxide. I'll put a very clean arrow around it. And it gives you 2 molecules of carbon monoxide, so I can write it like this. Now you can see that for the first carbon, when we talk about the first carbon, this one, it actually gets more and more oxygen around it. So this one is getting more oxygens around it by the end of the reaction like this. Initially the carbon didn't have an oxygen, but by the end of it, it has an oxygen. So that is a kind of oxidation process. It's a kind of oxidation. But for the other carbon dioxide, it had 2 oxygens already, but now it has only 1. So that must have been a loss of oxygen. And a loss of oxygen is a reduction process. So this carbon dioxide molecule is losing the oxygen, that is reduction. So when you get more and more oxygen, that's oxidation. When you lose your oxygens, that's reduction. In terms of hydrogen and oxygen, it's easier to find out how redox is going on because you don't have to worry about the charges over here. Let's talk about one more of such an equation, and let's call this done on the oxidation and reduction process in terms of hydrogen and oxygen. So let's try a difficult example. You'll use an arrow over here, and what you get is you get SO3 gas and you get water molecules. So the left side molecule is hydrogen peroxide, which is H2O2. What happens is that H2O2 reacts with SO2 gas, which is sulfur dioxide gas. It forms sulfur trioxide gas, and water molecules are here. Let's look at the S first. So the S is technically getting more and more oxygens around it. You can see initially it had only 2 oxygens around it, but by the end of it, it's getting more and more oxygens, so it's 3 oxygens right now. That has to be the oxidation process. So this one is an oxidation process from SO2 to SO3. It's an oxidation over here. Initially the sulfur molecules had only 2 oxygens, but now it has 3. So that's oxidation. Let's look at the H2O2. You can see it had 2 oxygens in the beginning, but by the end it has only 1. So it's a loss of oxygen, and that has to be reduction process. So during this process, the reduction is going on for the H2O2 and oxidation is going on for the SO2. So you can very safely say that when some element reacts with oxygen, any element or a compound, that's oxidation. The reverse is going to be reduction. Whenever something reacts with hydrogen, that's reduction, and the reverse is oxidation. So with this, and obviously the idea of loss of electron known as oxidation and gain of electron known as reduction, we can now very clearly say that redox reaction has 4 definitions. Redox has a reduction and an oxidation. Reduction means gain of electron to become a negative charge, or perhaps increase the negativity of the charge. It means to react with hydrogen gas and lose all the oxygen. Oxidation is the total reverse of it. So oxidation is the loss of electron to become a positive charge, or perhaps increase the positivity of the charge, to lose all hydrogen and gain more and more oxygen, or even perhaps react with oxygen. So right now we are done with the idea of redox. In the next class, or perhaps the next video I should say, we'll be talking about the idea of oxidation number to see how charges are perhaps hidden within the oxidation number. So next video is really going to be important for all of those who are perhaps troubling with oxidation number. So see you guys.